The chain rule is actually made from composition of functions. So you have to recognize when we have composition of functions, and then the chain rule will be really, really easy. So composition of functions is what you see in front of you, where you have the fog and Goff, or the f of g of x and the g of f of x. That means that one function is inside of another function. So if we have two functions such as we have here, and we have fog, that means that you're going to take the g and substitute it in for every x value of f of x. So when we have this, what we are going to get here is, let me draw. Okay, so what we have here is we're going to have um, the f, and we're going to put the g inside. So it's x to the seventh. Wherever we see an x, we're going to replace it. So that's going to be x to the 7 to the third plus 5. Anytime a power to a power, we know we are multiplying that. And so you get x to the 21st plus 5. So that's what you get when you put g of x inside of f of x. When you do Goff, that's the opposite. So you're going to take the g, and this time we're going to put the x cubed plus 5 inside of the g of x. So that means that wherever we see an x, we're going to replace it with the whole entire thing. So this is going to be x cubed plus 5 all the way raised to the seventh. And so that means that there is 7 of these. So you could expand it using um, Pascal's triangle and then be able to like do the power rule on it, or we could do the chain rule. So here, this one here is just a basic power rule if we want to take the derivative. So it's going to be 21x to the 20th and then plus 0. So that's the derivative of that. But if I want to take the derivative of this, instead of doing Pascal's triangle, expanding it all, making it a polynomial, and then doing the derivative of it, just like we did up here, all I have to do is do the chain rule. And so here is how we would do the chain rule. But let me explain the definition first of the chain rule. So what we have here is we're going to take the derivative of, and then we could do the function of g of x. So that's what they're saying. And by definition of the chain rule, it says that we are going to take the derivative of the outside function. And the outside function in this case here would be f. So we're taking the derivative of f. And we're leaving the inside function alone. And then we are going to chain on, this is why it's called the chain rule, chain on through multiplication the derivative of the inside. So it's going to be then the derivative of g of x. That's the official definition of the chain rule. Derivative of the outside, leave the inside alone, chain on the derivative of the inside function. So you have to recognize what is the outside function and what is the inside function. And you have to like break it down to composition of functions. So we know that the outside function was x to the seventh. So that's the outside function. And the inside function is your f of x um, to the third plus 5. So we're going to take the derivative of the outside function. So what we're going to have is f prime of x is going to be derivative of the outside function. So that's just an easy power rule. We bring down the 7 to the leading coefficient and we subtract 1 from it. So that's the outside function. We leave the inside function alone. So we leave the x cubed plus 5 alone. That's the inside function. And then you're going to chain on the derivative of the inside function. And that's just going to be 3x squared plus 0. Now, usually it might be longer, so we always put parentheses around what we're doing. In this case, we really don't need it because we really don't need that 0 and there's nothing else. So that's what the derivative is. And then through algebra, we just clean it up. And the actual derivative is going to be um, because this is by itself, because it's raised to the 6, this 7 and that 3 could be multiplied, and we get 21x squared, and then x cubed plus 5 to the 6. And that is your derivative using the chain rule. Let's do a couple of other ones. Here, There is no inside function or outside function. This here is just one term, a constant, and a polynomial. So if I am going to take the derivative of that, this f prime of x is just going to be 2x. Okay, so we're just taking the derivative of that. Now here, that's different. So notice how we have this part right here inside, and then you have the outside function, which is the square root. So the quadratic is inside the function, and you're taking the square root, which is your outside function. So now what you're going to do is, in order for me, anytime it's a radical, I'm going to use the power rule. So we need to change that. So we are going to change it to, let me just move that over here. And we're going to change it to 3 plus x squared. And then I'm just going to do a different color on that. And we're going to say to the 1/2. So the red is the outside function. This is the inside function. So what we're going to do is we're going to do the power rule like we always do. And it's going to be 1/2. And then this part right here is going to be, we're subtracting 1 from it. And so because we're doing the power rule, and then you get 2 over 2. So that gives you negative 1/2. And so we leave the inside alone. So I took the derivative of the outside function and I left the inside alone. Now we're going to chain the inside of it, but we already did that, and that's going to be the 2x that we already did over there, the derivative of the inside. And so we don't need parentheses because it's just one term, but we want to leave it nice. So the final answer is going to be, remember this is over 1, so we could bring it down, numerator to numerator, denominator to denominator, but since we're bringing it down, it's going to be, and then this one here is also over 1, and everything's being multiplied. So what we really get is 2x. That goes in the numerator. This comes down, and that's still in the denominator, and it's being multiplied. 3 plus x squared to the 1/2. The 2's, because everything's being multiplied, cancel out, and so your final answer is x over the square root of 3 plus x squared is your final answer, nothing else to reduce. So now we are going and we're just building it up. So here there was a composition of functions, and now we have a composition of functions inside of a composition of functions inside of another composition of functions. So now we have it in the exponent, so it becomes an exponential function. So how do I do the chain rule on this one? So here is how you do it. So you start the same way that you did before, the outside, then the inside, and then you keep going on there. So the outside function is e to the x. So we are going to take it just the way we would do the derivative of a e to the x. So the first derivative is we take the outside, and it's e to the x is e to the x, and so you leave that alone, and so you leave the inside alone, and so then we leave this, which is 3 plus x squared alone. Now we have to take that, we're going to have to chain on the derivative of the outside function. So the outside function is this 1/2. So now we're back to what we did up here, where we're taking the derivative of this. So you're going to do the exact same thing we did over here. We're going to chain that on. So we're going to chain on the 1/2, and then we're going to leave the inside alone, which is 3 plus x squared, but the outside remains the 1/2 to the negative 1/2. And then we're going to do the derivative of the inside. So then we're going to do that again and chain on the inside here, which is the 2x. So since we added, now we have a new member to our train. So here we go. And then you have to do the algebra to make it nice. So we know that this part from up here became this. So now I know that I am going to have equals, I'm just going to do that out in black, e to the square root of 3 plus x squared times what we solved over here, which is the square root of 3 plus x squared. This is over 1, so your final answer is e square root of 3 plus x squared times x, that's this x right here, numerator to numerator, denominator to denominator, all over 3 plus x squared. And so this here is the derivative of that problem right there. Okay, now let's just, for fun's sake, add one more thing to it. So now we have this part, but we start with the outside function again. So the outside function is the square root function. So I know that I am going to start that with 1/2, and then we leave the whole inside alone. So I am going to leave the inside plus e to the square root of 3 plus x squared. And then the outside function is going to be minus 1/2. So that's the outside part of it. And then we take the derivative of the red part, which is in the inside. This becomes, the first one is 0. And then we are back to the derivative of this, which is this, what we just did here. So we're going to rewrite all of that stuff again. So the derivative of that now is going to be chain on the derivative, which is 0. The derivative of v is going to be just e, and we leave the inside alone, which is the square root of 3 plus x squared. And so that's the derivative of that. We have to do the derivative of this one here. So we're going to chain on 1/2. And now we need to leave that derivative alone. And we're going to say 3 plus x squared. And this one here is going to have the negative 1/2 because of the power rule. And then we're going to chain the inside in. And so it's going to be 2x. Notice how we have the 2x, this, and that, and then this is really the only new stuff on there. And now that looks really crazy. But I already know that from here on is this. So I'm just going to change that. And I am going to say that this here is over 1, and this is 1/2. So I know I'm going to get 1 over 2, and then that's going to be the square root of 1 plus e to the square root of 3 plus x squared. So that's this part right there times this whole thing, which really is this. So it's going to be x e to the square root of 3 plus x squared all over square root of 3 plus x squared. And so then what you're going to have there is going to be multiply numerator to numerator. So your final answer, if we look at that, because nothing cancels, it's going to be x e to the square root of 3 plus x squared all over 2 square root of 1 plus e to the square root of 3 plus x squared times the square root of 3 plus x squared. And that's the full derivative with many chain-ons on there. So the main thing right now is you for understanding the basic concepts on there. And then as we go along, we'll learn the more difficult ones that we did down here. But you could always review this video again and again and then understand the chain rule.